The finite region capital R is bounded by the x-axis and the curve with the equation y equal to minus x squared plus 2x plus 3, where x is positive. Here we can see this is the area capital R shown starting from A to B on the x-axis. Now, the first part is find the coordinates of the point A and point B. So we solve it, and first we derive the equation. We are given y equal to minus x squared plus 2x plus 3. The first part, we are asked the coordinates of the points A and point B. As we are looking in the figure, the point A and the point B is on x-axis, and we know at x-axis the value of y equal to 0. So we replace the value of y equal 0 in the given equation to find the coordinates of the point A and B. So we put y equal to 0. We get 0 equal to minus x squared plus 2x plus 3. In other words, we also write x squared minus 2x minus 3 equal to 0. When we take minus common, we will get x squared. The other signs will be changed. Minus is positive, and the positive 2x will be negative 2x, and plus 3 is minus 3. Now, if we factorize it, then we will get x squared. The midterm will be breakdown in the pair minus 3x plus x minus 3. We simplify it. When we take common x, we will get x minus 3 plus, in the next two terms there is nothing common, so we will write 1. We get x minus 3 equal to 0. So we get x minus 3 and x plus 1 equal 0. Now simplifying more, we get x minus 3 equal to 0 and x plus 1 equal to 0. For further simplification, we get x equal to 3 and x equal to minus 1. Now we place the values of x in this given equation to find the coordinate of y. So we find for x equal to 3, we will get y equal to here minus x squared. This one equation, I say it's equation 1 minus x squared. In place of x, I will write 3 squared plus 2, and the value of x 3 plus 3. So I will get the value of y minus 9 plus 6 plus 3, y equal to 0. As these values of x lies on x-axis, so the coordinates of a and b will be the first one x minus 1 comma y 0, and the second one x3 y 0. This is the solution of the question. In the second part B, we have to find the area of region R. So we solve it. We are given y equal to minus x squared plus 2x plus 3. As we have coordinates minus 1 0 and 3 0, to find the area, we will write as the function. In the second part, we have to find the area of the region where we have found the points x minus 1 to 0, and the second value of x is 3 to 0. So we are given equation y equal to minus x squared plus 2x plus 3. We integrate it. Then we will get, we are given function minus x squared plus 2x plus 3. This is the function. We will integrate, and we are given the limits from minus 1 to 3 dx. When we solve it, we will get minus x square dx plus 2 into x dx plus 3 into dx. And we have limits 3 minus 1. When we solve it, we get minus x squared plus 1 by 2 plus 1, and applying limit minus 1 to 3 plus 2. The integral of x will be x 1 plus 1 over 1 plus 1. The limits will be minus 1 to 3 plus 3. Integral of 1 dx will be x. We will get 3 minus 1. Now, we further simplify it. We will get minus, here we get 3 x raised by 3. The limits are minus 1 and 3 plus 2 x 2 by 2 minus 1 3 limits plus 3. You will write it same as, remember that here is 3 is the upper limit and minus 1 is the lower limit. For further simplification, we write 1 by 3 minus, and we write as x cube 3 minus 1 plus 2 by 2 x square 3 minus 1 plus 3. We write it same as above. Now we will replace upper and lower limit and find the area. Minus 1 by 3, and here 3 in place of x, we will get 3 cube minus the lower limit minus 1 cube. Here 2 is cancelled out, we get x square mean 3 square minus 1 square plus 3. In place of x, we will write 3 minus the lower limit minus 1. So we get minus 1 by 3 cube, 27 minus 1 raised by 3 is negative. So negative will be positive. We get plus 1 plus 3 square 9 minus 1 square is positive. The answer will be minus 1 plus 3 minus plus, we get plus 1 minus 1 by 3. This is 28 plus 8 plus 3 into 3 plus 1 4 3 12 minus 28 by 3 plus 20. We get minus 28 plus 60, which is equal to 32 by 3. This is our required area. 11 in Excel Mathematics exercise number 13E. Here in this question, we are given this figure. We are looking here on x-axis. We have to find the point A and the point B. We are given equation y equal to x plus 3 2 minus x. The curve C, this is the curve C, crosses the x-axis at the origin and at points A and B, as we can see, A, origin, and B. The first part is write down the coordinates of A and B. We have to write the coordinate A and B. As we are looking, A and B lies on x-axis. Then A and B lies on x-axis, so we put y equal to 0 because y value on x-axis is always 0. So we put for y equal to 0. We get 0 x plus 3. On the right side, we write same as. Now we find the values at x at first. This one x equal to 0. Also x plus 3 equal 0 and 2 minus x equal 0. From here, we find the value of x equal to 0. And the second one is x minus 3. And the third one, if we put minus x to the right side, we will get positive x equal to 2. These are the three values of x which are we asked to find in the part A. Now for part B. Now in the B part, use integration to find the total finite shaded area. Here we can see A to origin. This is the shaded area, and from origin to B, this one shaded area. We have to find this is the total shaded area, and this area lies from minus 3 to 2. So we find the shaded area. Now we are given function f of x plus 3, 2 minus x, as we can see in the figure. Now we will integrate it where we have the values of x minus 3 to x equal to 2, as we can see from a to b, minus 3 to 2. First of all, we will integrate it and apply the limits. So we write minus 3 lower limit and 2 is the upper limit. And now we write the function x plus 3 and 2 minus x dx. And first, simplify the terms. We can multiply as like this. We write, when we multiply x with x plus 3, we will get x squared plus 3x into 2 minus x. Now we multiply x squared plus 3x by 2 minus x. We will get, after multiplying, we get minus x cubed minus 2x cubed plus 6x. Now we will integrate the function. When we integrate, we get minus x cubed integral. We write minus x cubed dx, upper limit 2 and the lower, minus 3, then minus x squared to minus 3 dx plus 6 to minus 3 x dx. When we integrate, we get minus x 4 by 4, and we write the limits minus 3 to minus x 3 by 3, minus 3 2 limits plus 6 x squared by 2 to minus 3 plus c. Now minus 1 by 4 and x4 to minus 3 minus 1 by 3 x cubed to minus 3 plus 6 by 2 x squared to minus 3. Now minus 1 by 4, we apply the limit, upper limit 2 in place of x, we get 2 4 minus the lower limit minus 3, there is part for the first one, minus 1 by 3. In the second, we are looking at x cube, so we write 2 cube minus 3 cube plus 236, we get 3, right? Upper limit 2 in place of x, we get 2 square minus the lower limit minus 3 square. Now we simplify it. Minus 1 by 4, 2 raised power 4, we will get 16 minus 3 raised power 4 minus 16. By this minus multiply, we will get plus 16 minus 1 by 3, 8 minus plus 27 plus 3, 4 minus 3, 9, negative 9. Now we simplify it, minus 1 by 4, 32 minus 1 by 3, 35 plus 3 into minus 5. By further simplifying, we get 4832 minus 8 minus 35 by 3 minus 50. When we solve it, 3, when we multiply 3, 24 minus 20, 35 minus 53, 45. So we get the area minus 10 by 104 by 3. This is our solution. In this question, the diagram shows the line y equal to x minus 1. As we can see, this is the diagram here. This is the line named as y equal to x minus 1, meeting the curve with equation y equal to x minus 1, x plus 5. This is the curve and its equation is y equal to x minus 1 into x minus 5. The line meets the curve at the point C and A. The curve meets the x-axis at A and B. As we can see, the curve meets at point A and at point C. Now, in question part A, write down the coordinates of A and B and find the coordinates of C. We have to find the coordinates A and B, and then we have to find the coordinate of the point C. First of all, we find the coordinates of the point A and B. Now we can see as the point A and B lies on x-axis, so we write at first y equal to x minus 1, x minus 5. This is the equation of curve, and y equal to x minus 1. This is the equation of line. As the curve cuts x-axis at the point A and B, and on x-axis, the value of y is 0. So we put y equal to 0 to find the points A and B. We put y equal to 0 in curve. We get x minus 1 into x minus 5. That is x minus 1 equal to 0. Also, x minus 5 equal to 0. From here, we find the value of x. The first one is 1 and second is 5. So, the value of A is x equal to 1. Now, point A will be value of x is 1 and the value of y is 0 because the point A lies on x-axis. Similarly, value of B, coordinate of B will be x is 5 and y is 0. Now to find the coordinate of the point C, as we can see, the point C is the point of contact of the line y equal to x minus 1 and the curve y equal to x minus 1, x minus 5. So that we have to find the point of intersection C. Now to find the point of intersection C, we will equate the equation of line and equation of curve. So we write x minus 1, which is the equation of line, will be equal to the equation of curve x minus 1 into x minus 5. So we find the point S. Now we solve this equation. We get x minus 1 equal to, when we multiply it, we get s squared minus 1 into minus 5. It will be minus 6x and minus plus we get 5 on the 5. We simplify it. We get minus x plus 1 equal to 0. This x minus 1, we bring it to the right side and the signs are changed. Now we get x squared minus 7x plus 5 plus 1 will be 6. Now we solve. By factorization, we get x squared minus 6x minus x plus 6. Here, take x common, we get x minus 6. Here, minus 1 is common, and we get x minus 6. So we write x minus 6 into x minus 1 equal to 0. Then x minus 6 equal to 0. Also, x minus 1 equal to 0. We get x equal to 6. We get x equal to 1. Now, now we have to find the shaded area which is bounded by the line and the curve and x-axis. At first, we draw perpendicular from the point C, which is shown here as x is 6. We have find the point C, which is having coordinates 6 and 5. So this will be then 6 on x-axis and 5 will be used for perpendicular, which is drawn here. So the area under the line and curve and x-axis will be the total area of triangle A at point C to be minus the area of the curve. Now we solve. We will write at first area of triangle minus area under the curve. For this, we will use minus area under the curve. We will write from 5 to 6. As we can see, 5 to 6. This triangle area under the curve. We will write equation of the curve, which is x minus 1 into x minus 5 dx. Now we solve it. The area will be area of triangle 1 by 2. Here base is 5. We can see the base over triangle 6 minus 1, it will be 5 into the height 5, which is shown here. This is the height. Y point is 5 minus, we will solve this integral. At first we multiply, we get x squared minus 5 minus 1, it will be minus 6x and then plus 5 dx. So area will be 25 by 2 minus, when we integrate it, we will get x 3 by 3 minus 6x square by 2 plus 5 into x. When we find this integral, we will apply limits 6 and 5 and then solve it to find the shaded area. 25 by 2 minus, we will apply the limit 6 cube by 3 minus 6 into 6 square by 2 plus 5 into 6. We have applied the upper limit minus, now we will apply the lower limit 5 in the function. We get 5 cube, we write in place of x 5 minus 5 into 5 square over 2 plus 5 into 5. Now 25 by 2 minus, we will get 6 cube, which is 216 by 3 minus 6 is 36 into 6, 216 by 2 plus 5, 6, 30. The first one minus 5, 3, 1 to 5 by 3 minus 5 squared 25 into 5 1 to 5 by 3 plus 5 by 25. Now we simplify it. We get 25 by 2 minus we have now we take LCM to find the values 3 to 6 3 to the 6 when 2 is multiplied by the numerator 216 we get 4 3 2 minus 2 3 3 multiplied by 216 we get 648 plus 30 multiplied by 6 we get 180 minus now we simplify this we take LCM here is 2 3 2 6 3 2 2 by 1 to 5 we get 250 minus 2 3 1 to 5 375 plus 150. Now we solve 25 by 2 minus we get minus 36 by 6 minus 25 by 6. So 25 by 2 minus here we get minus 36 minus 25. 25 by 2 minus negative 61 which will be positive 61 by 6 and now when we take its LCM we will get here the LCM is 6 2 3 75 plus this is 6 1 1 into 61 136 by 6 divide by 6 we get shaded area 22.66. This is the answer. We write shaded. We have to find the exact area R which is shaded in gray color. For this, we have to understand how to write integral formula. And first of all, we have to find the limits 0 and the second at the point B. When we will find this, then we have to write the integral formula. For the integral formula, we have to see the curve which is above. We can see this curve is above and this curve is below goes. Then when we write integral formula, first of all, we will write the equation of the curve which is above. That is, this curve is above. So at first, we will write this equation y equal to 1 by 2x square minus 5 by 2x plus 7. And then we will subtract the second equation of curve which is y equal to x square minus 5x plus 7. We can see the area of the above curve having equation y equal to x square by 2 minus 5 by 2x plus 7. Then we will see the area under this curve will be on x-axis at point suppose say C. The area OC which is under the curve, this one above curve having equation x square by 2 minus 5 by 2x plus 7, and then we will subtract the area under the curve which is second curve I am showing here having equation y equal to x square minus 5x plus 7. Then we subtract the area under the above curve minus the area under the below curve. Then we will find the exact area R. Now to find the point of intersection, we have to equate equation 1 and equation 2. Suppose equation 1 is the first equation of curve x square by 2 minus 5x by 2 plus 7. This is the first one equation, and the second equation will be y equal to x square minus 5x plus 7. Now to find the point of intersection, we will equate both equation 1 and 2 We will write equating equation 1 and 2. We will equate both the equations, that is, the first one x squared by 2 minus 5x by 2 minus plus 7 equal x squared minus 5x plus 7. For this, we will take LCM from the left side. So now we will write at first 2x squared minus 10x plus 14 minus x squared plus 5x minus 14 equal to 0. We have converted the left terms to the right side and the signs have been changed. Now we can see 2x squared minus x squared, we will get x squared minus 10x plus 5x equal minus 5x, and plus 14 minus 14 will be cancelled. We will get, here we get common x minus 5. Now here is x is 0 and the second one x minus 5 equal to 0. Now x will be 5. So we have found the point of intersection and the limits. Now area will be area under the curve. At first we will write above curve, which is above. We can see this one is the curve above, that is y equal to x squared by 2 minus 5x by 2 plus 7. Area under the curve y equal to x squared by 2 minus 5x by 2 plus 7 minus area under the curve y equal x squared minus 5x plus 7. So we will write area R will be integral. The lower limit we have x equal to 0 and the upper limit x equal to 5. At first we will write this equation x squared by 2 minus 5x by 2 plus 7 minus integral 0 to 5. Second curve will be x squared minus 5x plus 7 dx. By this way we will integrate and find out the area R. Question 24. The graph shows a sketch of part of the curve C. Here, this is the curve C with equation y equal to x into x minus 3x plus 2. As the curve crosses the x-axis at the origin, we can see the curve, this curve crosses x-axis at the point A to at point O and the point B. Now, first of all, we have to write the coordinates of the point A and B. Now, as the curve crosses x-axis, so we will put y equal to 0 because on the x-axis, y values is always 0. We replace y as 0. We find the values of x. Now we get x 0, also x minus 3 second value 0, and x plus 2 the third value also 0. From here we get x equal to 3 and x equal to minus 2. Now the point A will be, as it is negative x-axis, so A will be minus 2, 0, and B will have coordinate. Here x will be 3 and y 0. These are the coordinates of the points A and B. Now we use integration to find the total area of this region. Now we have to find the total area of this region. For this we write, as we can see, area under the curve from A to 0 is above the x-axis and the area from 0 to B is below the x-axis. So the integral formula for area of the curve will be